Okay, gentlemen, good morning. So we will see our third webinar. So before going to the webinar, I'll just introduce myself. I'm Sanal Hubert Matthews. I'm the principal consultant and director of Canotech Engineering Consultants. So I'll give a brief introduction about our company. We are design and consulting consultants serving marine oil and gas sector. So our main focus is on piping and instrumentation process control sector. We are specialized in providing entire services for piping and instrumentation control services. So this is our third webinar. Earlier we had a webinar on piping, just an introduction on piping. Similarly, we had a webinar on valves to discuss various types of valves, application, how it applies in the industry, how to select a valve. So these videos are available in YouTube. If any of you are interested, just check our company website to get the link to YouTube, or you can directly contact me through email if you want the video directly through me. Okay, so before going to the webinar, I'll tell about the platform which we are using, Soho. So here there is a Q&A section, and similarly we have a poll section. So if you launch a poll, you will get the poll on the screen to select the right answer or your choice of answer. Similarly, if you have any doubts or any questions during the presentation, please click on the Q&A section and you can post it on the Q&A. We will have a discussion at the end of webinar to cover all the topics, like to clear any clarifications. So during the presentation, we will not be stopping just to keep the flow of presentation. But please put the doubts in the Q&A or note it down, or we can discuss it at the end of the presentation. So we will go directly to the presentation. The topic is pumps. So we will see the webinar agenda. Just we will be discussing about the pumps, like where all it is applied, what is the application, what are the types of pumps. Like we may have a doubt, why can't we use a pump for all applications? Because each pump has certain advantage, disadvantage. So we will discuss about all those types. We will see what all materials, how to select a material, like what are the standard symbols. Symbols is just for our information. When we see in a drawing, we have to recognize which type of pump. So we will see what all symbols available. Similarly, we will see the selection criteria and general details, like what all pumps are we seeing in the industry, why certain pumps are widely seen and why some are not seen much. So those things we will discuss, and we will go to the Q&A section. Okay, so talking about the industries, we can see the pumps in all the engineering sector. I have named very few, like marine, oil and gas, power plants, process plants, mining, sewage processing, food, chemical manufacturing sector, etc. So any industry which has a piping system or which has an equipment which needs a fluid has a pump, because this is like if we compare a human body, like the heart is the pump in our human body. Similarly, pumps are means each system will have a heart, like each piping system has a heart. In the industrial plants, it is the pumps which serve as the heart. So we will see what a pump is like. It is a device. It can move fluid by mechanical action. So this fluid can be gases, liquids, solids, or slurries. Anything can be a fluid. So also it is operated by some mechanism, like it consumes energy. For moving the fluid, we need to supply some form of energy, like either it can be electricity, or it can be an engine driven pump, or it can be a turbine driven pump. So a lot of options are there. or it can be a manual pump, which we generally don't use much in the industry. We use energy supplied pumps, like either through electricity engines or like turbine driven. Okay, so now we will see the types of pumps. So widely it is classified into two, like dynamic pumps and positive displacement pumps. So under dynamic, we see centrifugal. That two types are there, vertical and horizontal types. Similarly, we have submersible pumps and fire hydrant pumps. Also, in positive displacement, we can see piston pump, gear pump, diaphragm, lobe, peristaltic. So this does not cover the entire section of pumps. Actually, there are a lot of other types of pumps, but we widely classify into two, like dynamic and positive displacement. So under this, these are the pumps. We will go through each. There is a separate section for each in the coming slides. Okay, so we have a doubt right now. Why we have, what is the difference, dynamic and positive displacement? Why can we use the same pump for our all application? So we will have a comparison to see what is the difference. Like, for example, viscosity. Here it is mentioned centrifugal and positive displacement, because under the dynamic pumps, centrifugal is the major pump which covers the most of the industries. So we will see what is the effect of viscosity. Like for a centrifugal pump or a dynamic pump, efficiency decrease with increasing viscosity. But on the other hand, if you go for a positive displacement, efficiency increase with increasing viscosity. So this difference has to be considered when we select a pump. Okay, so when we see the pressure, like for a centrifugal pump or which is a dynamic pump, the flow varies with changing pressure. So that is something to be noted. Similarly, for a positive displacement, flow is insensitive to changing pressure. So if the pressure changes, also the flow does not vary. The flow is constant. So priming is required for dynamic pump. Positive displacement pump does not need priming. We will see that in the future slides. We will see in detail. Similarly, the flow of a dynamic pump, which is here mentioned as a centrifugal pump, is constant, but positive displacement, it is pulsating. Like pulsing means it is pulsating. There will be a high flow, low flow, high flow, low flow, which we can see in the line itself. So these are the differences. Now we will see what type of pumps we have. So dynamic pumps is widely classified like a centrifugal, vertical, different types of flow, like based on flow, radial flow, axial flow, mixed flow. We will see these types in detail. Similarly, if we have different types of suction, like single suction, double suction. Okay, so also the shroud construction, etc. We will not go into that deep, but we will see the in the next slides. Okay, so before discussing centrifugal pump, we will see a video on centrifugal pump to just get an idea how it works.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will have a conceptual overview of working of centrifugal pumps. At the heart of the system lies the impeller. It has got a series of curved vanes fitted inside shroud plates. The impeller is always immersed in water. When the impeller is made to rotate, it makes the fluid surrounding it also rotate. This imparts centrifugal force to water particles, and the water moves radially out. Since rotational mechanical energy is transferred to the fluid at discharge sides of impeller, both pressure and kinetic energy of water will rise. At suction side, water is getting displaced, so a negative pressure will be induced at I. Such low pressure helps in sucking fresh water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air at eye of impeller will be negligibly small to suck fresh stream of water. Impeller is fitted inside a casing, so the water moving out will be collected inside it and will move in the same direction of rotation of impeller to the discharge nozzle. Here you can note one specialty of casing. It has got increasing area along the flow direction. Such increasing area will help in accommodating newly added water stream and will also help in reducing exit flow velocity. Reduction in flow velocity will result in increase in static pressure, which is required to overcome resistance of pumping system. Here you can see more details of vanes inside impeller. They are backward curved vanes with state-of-the-art eye configuration. This vane is extracted from a Kirloskar pump model. If pressure at suction side of impeller goes below vapor pressure of water, a dangerous phenomenon could happen. Water will start to boil, forming vapor bubbles and spoil impeller materials over time. This phenomenon is known as cavitation. More the suction head, lesser should be the pressure at suction side to lift water. This fact puts a limit to maximum suction head a pump can have. Careful pump selection is required to avoid problem of cavitation. Current impeller type is enclosed. Semi-open and open impellers are also in use depending upon application. If the working fluid is cloggy in nature, it is preferred to use open kind of impeller, but they are slightly less efficient. Mechanical design of centrifugal pump is always challenging. A shaft is used to connect between the impeller and motor. Since water pressure inside casing is huge, a proper sealing arrangement is imperative in arresting water leakage through shaft casing clearance. Mechanical seal or stuffing box-based mechanism is used for this purpose. Impeller is mounted on bearings, but at suction side of impeller, it is not advisable to fit a bearing since it will block the flow. So bearings have to be fitted at the other end. This means impeller is mounted like a cantilever. For high flow rate pumps, a bearing housing with cooling oil is necessary for improving life of bearings.
Okay, so that was about centrifugal pumps, just a video, but we will see in detail. So first picture is a centrifugal pump installed at site. So second is the one which describes the parts inside a pump. Like we can see the suction side, discharge side. So there is an impeller, which is the one which churns the water. So shaft is driving, which provides drive to the impeller. So other side there will be there can be either an electric motor. The first picture which is showing is with an electric motor. Similarly, we can couple an engine, the engine also for providing a drive. So there is a casing for the pump, as seen in the video. So in this one, just it shows how the fluid enters and the direction fluid leaves. Okay, so we'll see the next slide. Okay, speaking about centrifugal pump, this is the most commonly used type of pumps which we see in the industry. Any professional working in the marine sector or in the process sector or in the oil and gas sector, will see the centrifugal pump application in a wide manner. So we will see what is because why it is being widely used, because it can handle both viscous fluid and non-viscous fluid. Okay, so basically it is called centrifugal pump because it works by the use of centrifugal force. Like the impeller rotates and it creates a low pressure and the impeller area, like at the eye of the impeller. So this low pressure pulls the pump actually, it creates a suction, like because of this low pressure, the fluid from the high pressure reservoir area flows to the low pressure area. So this is how the suction is created. And when we deal with centrifugal pump, we have to know two factors like Npsh and cavitation. We saw in the video a small brief about it. So Npsh is net positive suction head, and we will see what is cavitation. So this is a diagram just showing a water sump and the suction pipe pump is installed. So the HS is the suction height, or we call it a suction head, and the delivery pipe is shown and the overhead water tank. So HD is the delivery head. So this pump, when it works, it takes water from the water sump at the bottom and pumps it to the overhead tank. So we will see in detail. So as we already discussed, Npsh, so net positive suction head. Actually, we may have a doubt what is Npsh. So it is a measure of pressure experienced by fluid on the suction side of a centrifugal pump. So any centrifugal pump will have an Npsh value because that is a pump property. We can call it Npshr or Npsh required. So this is given by pump manufacturer. They test the pump in ideal conditions in their room environmental condition, and they give Npsh required for the pump for safe operation. So that value will be provided by pump manufacturer. Similarly, the system, I mean our tank location, our height requirement. So based on that, the system, we can calculate Npsha, which is Npsh available. So suction side pressure less the vapor side pressure of the pump fluid at the point. So that is Npsha. Like what is the suction side pressure minus the vapor pressure of the fluid. So we will not go into a calculation detail right now, but we have to know that there is a factor Npsh required, which will be provided by the pump manufacturer, and Npsh available, which we have to calculate for the system. So Npsh available should be higher than Npsh required for safe operation of pump, like to prevent cavitation. We will see what cavitation is in the next slide. So, and there should be a margin like minimum 0.5 meter or 10%, whichever is higher. Like minimum, there should be a 0.5 meter difference between Npsh available and Npsh required. Okay, so we will see that in the next slides. For example, if we see this slide, we can see on the first picture A, B, C, D. That is a 4 points actually. So the next diagram is showing the graph of pressure and vapor pressure is marked in a dotted line. So when the pump is in operation, we can see that the pressure drops. Pressure drops at the point B, which is at the eye of the impeller. That is the lowest pressure area in a centrifugal pump at the eye of the impeller. And after that, we can see that the pressure rises. So the bubble formation, when the graph goes below the vapor pressure, I mean if the pressure drops at the impeller area below the vapor pressure of the fluid, bubbles form. These bubbles are actually boiling. We call it bubble, but the fluid is actually boiling. If it is water is actually boiling. So which forms bubbles, and these bubbles collapse when the pressure rises above vapor pressure. The formed bubbles collapse on the impeller. It is like hitting on the impeller, which creates pitting or removal of metal, huge vibration, huge sound. So pumps which create vibration sound, we know there is cavitation happening inside, which has to be addressed. So that is the graphical representation seen here. We will not see this video, it's very long. We will go to Just a minute. We'll go to the. Okay, before going to the next slide, we will just describe what cavitation is. Cavitation is like, see, if you take water in a glass or in a bowl, there is an atmospheric pressure acting on the water. So there is one atmosphere, 1 bar. We tell it as 1 bar. So in this atmospheric pressure, we tell the boiling point of water as 100 degrees Celsius. But if we lower the pressure acting on the water, like vacuum, if we are able to build a vacuum, or if we are able to lower the pressure acting on the water, the boiling point can be reduced. Boiling point can even be brought up to 20 to 25 degrees Celsius. So water will boil at 20 to 25 degrees Celsius if we can create a vacuum condition. So this is what is happening inside the pump. At the eye of the impeller, the pressure is lower than atmospheric pressure. So when it is lower, this fluid has a tendency to boil. So that is the vapor pressure of the liquid, which determines the boiling point. So if the pressure drops below the vapor pressure, then the fluid boils, which creates the bubble. So this bubble, again, when the pressure regains, the formed bubble hits on the impeller or hits on the body of the pump, which creates cavitation. So basically, this is the condition. We'll see the next slides for comparison. Okay, now based on the water flow, we will see what all types of pumps are there. Three flow are divided into three, like axial flow pump, radial flow pump, mixed flow pump. So first we will see what is the difference. So axial flow pump is widely used where we need high flow rate and low pressure application. Similarly, radial flow pump, we can achieve high pressures with low flow rate. Also, we have a mixed flow pump, which is a medium, like flow rate and pressure will be medium. We will see in detail. So this is a video.
One way that centrifugal pumps can be categorized is by the way liquid flows through them. Three common flow path classifications are radial flow, axial flow, and mixed flow. In centrifugal pumps that have a radial flow design, the impeller causes the liquid to make a 90-degree turn and flow outward, or radially, from the suction eye to the tips of the vanes. A radial flow pump takes advantage of the maximum amount of centrifugal force that the impeller develops. Generally, radial flow pumps are capable of higher discharge pressures, but they don't move as much liquid as other types of centrifugal pumps. In centrifugal pumps that have an axial flow design, the impeller moves the liquid through the pump along a path that's parallel to the pump shaft. In this type of pump, the liquid is moved mainly by the propeller action of the impeller's vanes. This impeller uses only a small amount of centrifugal force to move the liquid. As a result, the discharge pressure of an axial flow pump tends to be lower than that of a radial flow pump. However, an axial flow pump may be able to move large quantities of liquid. Mixed flow pumps combine the characteristics of radial flow pumps and axial flow pumps. They use centrifugal force and the propeller action of the impeller's vanes to move the processed liquid. For that reason, a mixed flow pump can develop a relatively high discharge pressure and still move a large quantity of liquid.
Okay, so we saw about the three types. Actually, radial flow, which has the 90-degree flow direction. Similarly, axial flow, which has a parallel flow, which creates a parallel flow, which can achieve higher velocities but lower pressure. And mixed flow pumps, which are widely used because it can achieve the medium, like flow rate and pressure. It can achieve medium. So the figure which we are seeing right now is an axial flow pump. There is a propeller, or we can call it the impeller, like there is a drive shaft, and we can see that the flow is parallel to the propeller or impeller. Okay, what is the advantage of axial flow pump? We already discussed. It can achieve high flow rates and can be adjusted for best efficiency at varying conditions. But disadvantage is lower head or lower discharge pressure, and it is not suitable for suction lift because suction lift is like lifting from a tank. The axial flow pump is not suitable for suction lift. And it is also called as propeller pump because of the shape of the impeller. Like it looks like a boat propeller, so it is also known as a propeller pump. Now we will see a radial flow pump. In the radial flow pump, we can see that the suction comes to the eye of the impeller. If you see the first picture, and the discharge is at 90 degrees. So basically, the flow is turned to 90 degrees, and the impeller eye is the lower pressure area in a pump. Okay, so this is a radial flow pump. Just a more detailed view. We can see the impeller, suction port, discharge port. This is a diagram of a mixed flow pump, which we already discussed. Okay, now we will see centrifugal pump vertical type. So in the diagram, we can see that the pump is vertical. This is designed for vertical installation. Main advantage is we can save space. Wherever space constraint is there, we can use a vertical centrifugal pump. And it is suitable for low viscosity liquids. And we can use it for higher pressure temperature. The disadvantage is we need more headroom for installation. Like the pump will have more height. So we need that height space for installation. And we can only use electric motor as drivers, not engines or turbines. We can use electric motor, which is installed on top of the pump body. So this is about vertical type. Now we are seeing a horizontal type pump, horizontal type centrifugal pump. So this is basically used for horizontal installation. The advantage is this needs less headroom, but we need a higher footprint. Like the base floor area, we consume more space compared to a vertical pump. Another advantage for this is it is easier for installation and maintenance is very easy because all the parts are easily accessible. Not like a vertical pump. Vertical pump, because of the height, maintenance is a bit difficult. So horizontal pump has a maintenance advantage, and working temperature and pressure is comparatively lower compared to a vertical type. And another advantage, it can be coupled to motors, engines, or turbines. So these are factors which determine the selection of a pump. This space factor, which drive we are using. So what footprint available in the room space. So these are factors which decide which type we go for. We will go for vertical or horizontal. Another type of centrifugal is submersible pump. This is submerged in the fluid. It has many advantages. We will see a video on the submersible pump.
KSB offers you a comprehensive range of reliable submersible borehole pumps and high-performance motors designed to ensure a dependable and cost-effective water supply. Submersible borehole pumps are frequently used in narrow wells. As they are often installed several hundred meters underground, the pump sets are difficult to access. To generate the necessary heads, a multi-stage pump design is usually required. The pump head increases with each stage. However, the increase in pressure also generates an axial thrust which pushes the rotor downwards. The resulting force rises with each stage. To ensure reliable operation, the thrust bearing in the motor must be able to absorb and balance the forces without significant wear. To meet these requirements, KSB develops the Z pump. The back-to-back impeller arrangement on a single shaft balances axial thrust, reducing the load on the bearings to a minimum. The radial bearings and casing wear rings are made of particularly wear-resistant materials to ensure reliable operation for as long as possible. The respective motors are also developed and manufactured by KSP. In addition to optimum efficiency, achieving the maximum service life is also a priority here.
Okay, that was about submersible pump. So where we use submersible pumps, we will see like sewage treatment plants, water well, deep well drilling, offshore drilling rigs, mine dewatering irrigation systems. In the offshore drilling rigs, we can see that the raw water pumps, which are lowered to the sea, like when the offshore drilling rig moves up, the height varies in different locations. So because of the height variation, we use raw water pumps, submersible type. So the submersible type pumps are dropped into the sea, like using a raw water tower. So that is a separate design. We will not be discussing in detail, but raw water pumps are submersible type pumps which are used in offshore drilling rigs. Similarly, for deep well drilling, for mine dewatering, like water well, where space is less, we use a submersible pump, which is submerged inside. It has many advantages, like cavitation is very low in a submersible pump because it lies in the water. We get the static head advantage. There is no suction lift required here because the fluid is inside the pump is inside the fluid. Okay, now we will go for the next type, like positive displacement pump. Earlier we discussed about centrifugal pumps, which comes under dynamic pump category. Now we will go for positive displacement pump, which is a second category. Different type of pumps are there. First is a diaphragm pump. This is used in the industry widely, like air supply or other kind of operation. So we will see how it works. The first is a picture of the pump, and second is how it inflates and deflates. This is a double diaphragm type pump. So how it operates, we will see in a video.
This is a Wilden PX 1500 76mm 3-inch advanced aluminum pump. The liquid chambers are alternately filled and emptied by fluid that is drawn through a common inlet and discharged through a single outlet. The diaphragms in each chamber are linked by a single shaft, allowing them to move in unison. The air valve directs pressurized air to the back of diaphragm A. This begins chamber B's suction stroke, which starts as diaphragm B is moved toward the center of the pump, thereby creating a vacuum in chamber B. Atmospheric pressure then forces fluid into chamber B past the inlet ball valve. When the pressurized diaphragm A reaches the limit of its discharge stroke, the air valve redirects pressurized air to the back of diaphragm B. This begins the discharge stroke of chamber B. The hydraulic forces developed inside of chamber B force the inlet ball onto its seat and the discharge ball off its seat. This condition allows fluid to flow through the pump discharge. The same process occurs in the opposite chamber, constituting one full cycle. The pump will continue to run until inlet air supply is interrupted or discharge pressure rises to equal that of the air inlet pressure.
Okay, so that was about the diaphragm pump. We know it is a positive displacement pump. It is also known as a membrane pump because the diaphragm membrane, which is used here. We can use it for high, low, or medium viscosities. So wide application, we can use the pump. There is a reciprocating action of rubber, which we saw in the video. And the advantage of this is it can handle chemicals like acids, as they are assembled with extensive range of materials. Like for chemicals, we can use different suitable materials. So this is widely used for many applications. This is even a portable pump. We can see in the like if we go for marine vessels or if we go for offshore oil rigs, we can see this type of pumps, permanently installed types for bilge applications, because there will be a few dirt and solid oil, all kind of mixtures will be available in the bilge water. So we see this type of pumps mainly in bilge systems, and for cleaning up purpose, which is a portable type. But if we are using it for a bilge part of a system, it will be a permanently installed type, and it can be a portable type also. Okay, so now we will see a gear pump. What is a gear pump? Like it will have a drive gear and there is an idler gear. This is widely seen for hydraulic system application, like hydraulic power packs will have a gear type of pump, and it is compact and simple with a limited number of moving parts, suitable for pumping oils and other high viscosity fluids. There are two types, external gear pumps and internal gear pumps. We will see the type difference in the next slides. So application wise, we do not see gear pump used for low viscosity fluids, like for water application. We do not use a gear pump. It is used for pumping oils. We'll see the video.
External gear pump uses two gears rotating against each other to provide fluid movement. One gear is driven by a motor connected to a shaft. This is called the drive gear because it is driven by a motor, and it in turn meshes with and drives the movement of the second gear. As the gears rotate away from each other and come out of mesh, they create an expanding volume on the inlet side of the pump. This creates a vacuum at the inlet port, allowing fluid to flow into the pump. Then fluid flows into the cavities and is trapped by the gear teeth. As the gears rotate, a flow path is created around the outside of each one. Fluid trapped in the slots between teeth is carried around and discharged into the cavity with the outlet port. Meshing of the teeth in the center of the pump seals the outlet port from the inlet port. No fluid passes between the gears. The advantages of external gear pumps are their high speed and pressure, relatively quiet operation, and that their design accommodates a wide variety of materials. Disadvantages include bushings in the liquid area can become worn and that they have fixed end clearances. Internal gear pumps are exceptionally versatile. This type of pump has one inner gear, which is inside a second outer gear. The inner gear has a shaft driven by a motor and has teeth that protrude outward. The outer gear has teeth that protrude inward toward the center of the pump. As the inner gear rotates, it meshes with and moves the outer gear. Liquid is trapped in the gear spaces and carried from the inlet to the discharge. A stationary crescent-shaped divider separates the intake and discharge portions of the fluid. Advantages of internal gear pumps are a smooth and almost pulseless flow and slightly more horsepower for its size. Disadvantages are its higher cost, limited size range, low to moderate pressure ratings, and few sources of manufacture.
Okay, so that was about the difference of gear pumps. So we can see like various applications of fluids here. Like for fuel oil, lube oil, we can use both type, external or internal type. Similarly, for alcohol solvents, we can use both type. But for chemical mixing, chemical additive, like acids and caustic, we use external gear pumps only. And for paints, soaps, glycol, food products mainly, we use internal type. So that is a different application based on different fluids where gear pumps come into use. And the gear pump, actually the external gear pump can withstand more higher pressures compared to an internal gear pump. But when it comes to viscosity of fluid, we prefer internal gear pump. If the fluid is very highly viscous, we prefer an internal gear pump. And the gear pump, there is another disadvantage which we see in the gear pump, like there is wear and tear because of the gear meshing together, which is prevented in another type of pump, which you will see in the future slides. Just a brief description about peristaltic pump. This is used for handling sterile or highly reactive fluids. Like it is used in the blood circulation during bypass surgery, like that. In this, we can see a tube. The fluid flows inside the tube. Fluid does not come into contact with any other part of pump. And there is a rotating rotating rotor inside, which has two wheel type, which presses to the tube. So it rotates and the tube is pressed. You can see the blue color of liquid which flows through the tube. So this is used where the fluid which should not come into contact, like blood circulation, blood during a bypass surgery. It can be pumped using this pump because blood does not come into contact with any pump part. It only flows through the tube. Similarly, other reactive fluids or any chemicals or sterile fluids, etc., we can use this type of pumps. This type of pumps we don't generally see in the marine offshore sector. In the industrial sector, we see this very less, except in chemical plants or chemical or extremely reactive fluid applications, etc. So this is a low pump. This pump has the advantage, like other compared to gear pump. This pump has many advantages. This is widely used in the food processing sector or biopharmaceutical manufacturing sector. It is very highly efficient for viscous fluids, easy to maintain, and efficiency is compromised if you use a low viscosity fluid. Generally, we don't go for a low viscosity fluid for gear pumps, low pumps, etc. So in this case, we will see how a low pump works.
One of the most common pump types in the food and pharmaceutical industry is the rotary low pump. Viking's line of hygienic pumps by Right Flow Technologies includes low pumps with model sizes and designs to cover a wide range of pumping applications and hygienic requirements. Low pumps are similar in pumping action to external gear pumps, but differ in that the rotors are driven independently on two rotating shafts. A pair of external timing gears ensure that the rotors do not contact. As the rotors turn, a cavity is formed at the inlet side of the pump. This creates a vacuum to pull the liquid into the spaces between the tips of the lobes. This liquid is trapped between these lobes and the close-fitting casing wall. The rotation of the rotors carries the liquid around to the outlet side of the pump. The liquid does not pass between the rotors. At the outlet, the meshing of the lobes forces the liquid through the outlet port. Because of the large pumping cavities and non-contacting design, these pumps are ideal for the gentle handling of both thin and viscous liquids and liquids containing large solids. They are designed to be easily cleaned, making them ideal for applications requiring sanitary construction and frequent cleaning.
Okay, so that was about low pumps. The low pump advantage, we saw the advantage. It is very efficient. It can be used in food sector, biopharma sector, etc. And the wear and tear is comparatively much lower. But the thing is, it is very expensive compared to a gear pump. It's very expensive. So selection of this pump determines the cost factor and the application sector. Okay, now we will see a piston pump. Here, actually, we can move liquids or compress gases. Like for high pressure operation, we use a piston pump. Viscous media and media containing solid particles can be pumped. The thing is, the flow is pulsating because here the pistons are working. we get less flow rates, maintenance cost is high, it is very bulky and heavy, but where we need high pressure, we prefer piston pumps.
An axial piston pump is a pump that has a number of pistons in a circular array within a cylinder block. There are two designs are most relevant, the Swashplate configuration and the bent axis configuration. In both cases, the angle the Swashplate or the bent axis mechanism determines the effective stroke of the piston. Bent axis pumps design. In a bent axis piston pump, the cylinder block turns with the shaft but at an offset angle. The piston rods are attached to the drive shaft flanged by ball joints. Most bent axis piston pumps consist of a few basic components. Port plate, spherical siding surface, drive flange, drive shaft, shaft seal, flange, retaining rings, housing, bearing, piston, axis, cylinder block. The bent axis mechanism is a pumping machine, the displacement pistons of which are arranged at an angle to the drive shaft axis. As the drive shaft rotates, the cylinder block is caused to rotate by the pistons. The pistons move up and down within the cylinder block bores. The length of stroke is dependent on the angle of the bent axis. Fluid is fed to the low pressure, then, as the pistons moves, delivered into the high pressure port. Swashplate piston pump design. Most swashplate piston pumps consist of a few basic components. Flange, shaft seal, bearing, swashplate, drive shaft, piston, cylinder block, housing, port plate. The swashplate mechanism is a displacement mechanism, the displacement pistons of which are arranged axial to the drive shaft. The reaction force of the pistons is carried by the swashplate. As the drive shaft rotates, the cylinder block is driven by means of spline. The pistons move up and down within the cylinder block bores. This movement is dependent on the angle to the swashplate. Fluid is fed to the pump via the low pressure side, then as the pistons moves, delivered into high pressure line.
Okay, so this type of piston pumps we can see in the automobile application. Similarly in the equipment, etc. we can see. So now we will see the pump materials, like what are the materials available, like cast iron, stainless steel, bronze, nickel, alloys, iron-based alloys, etc. We will see in detail how the material application comes inside. For example, cast iron, which is a cheap option, like cost is it's very inexpensive, and it is used for general purpose pumps, irrigation, mining pumps, etc. Good corrosion resistance and to neutral and alkaline liquids. Suitable for high temperature applications. It is not suitable for acids. We will see where cast irons are selected. Like for seawater application, we can use a cast iron body pumps for cheaper application. But for long-lasting application, we go for different material. We will see. Next is the bronze material. Like here, this is a standard and cheap option. It is not much inexpensive compared to cast iron. It's a slightly expensive one, but comparatively it's cheaper. It's commonly used for impellers as its corrosion resistance is higher than cast iron. Similarly, high resistance to chloride. We can use it for seawater, offshore oil and gas application, power generation, aggressive bore water environments where the water is having a caustic property. Also, the wear and rate is very lower and high compression strength. So even the pulsating flow, it can adjust, the material can adjust different flow conditions. Next, we will see duplex material. It is highly resistant to corrosion, water treatment, seawater, fire pumps, oil and gas applications. So widely we see the application of duplex or stainless steel pumps in oil and gas application. It's expensive, but the advantage is it's long lasting. So highly preferred for oil and gas facilities, which need long lasting equipment. So this is a life factor of different material. We can see that the cast iron has 1.5, bronze has 4, nickel aluminum bronze has a factor of 8. So based on the requirement, based on the life factor requirement, we go for selection of suitable materials. We will see a few standards like ANSI API, DIN standard, German standards, ASME American, BS British standards. So these are few standards which are used for the manufacturing or selection of pumps. Okay, we will see a few pump symbols like centrifugal pump. What is the symbol? There is an arrow which is seen. Usually the arrow shows the direction of flow. Similarly, we can see gear pumps where 2 circles are seen, which are 2 gears. Rotary piston has a piston type symbol. There is a reciprocating pump symbol which you have seen. There is a diaphragm pump which we discussed. We can see the symbol for diaphragm. So these are symbols which are widely used in the diagrams. Also, now we will see the pump specification. How do we specify a pump? We need to mention the flow rates, what flow rate required. Like it can be meter cube per hour, liters per minute, or gallons per minute, GPM. Similarly, there should be a pressure which should be mentioned, like PSI, pound square inch, or bar values. Also we need to know the fluid medium, like for corrosion property, viscosity. For selection of a pump, we need to know the fluid medium, how viscous it is. Based on the earlier we discussed, for low viscosity fluids, we prefer centrifugal pumps, and for high viscosity fluids, we prefer gear type pumps or low pumps, etc. Similarly, temperature of fluid affects the pump selection, like which is mentioned in degrees Celsius, Fahrenheit, etc. Also, the life period, it depends on the pump selection. Life period is very important. Frequency of operation, then drive source, whether it is an electrical or an engine driven source. If it is an electrical driven source, we can go for, if we are selecting a centrifugal pump, we can go for vertical or horizontal type. But if we are going for an engine driven model, we have to go for a horizontal type generally. Then available space for installation has to be seen. This is a factor which affects the pump selection. If we have less footprint or less space available, we go for a vertical type pump, which needs a headroom area. So we have to see whether headroom available or not. Or if the headroom is less, but we have more space on the ground or on the floor, we can go for a horizontal type of centrifugal pump. Similarly, temperature of fluid, which we discussed here, it affects the cavitation factor. So that is something which has to be taken into consider. Also, the fluid medium, the corrosion viscosity factor affects the pump selection. So we will see the pump specification. How do we specify a pump for procurement? Like first is a centrifugal pump, vertical type. We are mentioning it as vertical type. Flow rate is mentioned, 100 meter cube per hour. At 100 meter TDH, there is a total delivery head. So total delivery head is mentioned. Delivery head we mentioned for centrifugal pumps, and pressure in bars we mentioned for gear pump or other post displacement pump. Also, we mentioned here on the first one, cast iron body or casing, bronze impeller, stainless steel shaft, flange to ANSI class 150. So flanges will be rated for ANSI class 150. Fluid we mentioned there, seawater at 32 degrees Celsius. Assembly to include suction and discharge side gauges. So this is the description, brief description which we give for a pump. We have to give more details like what type of motors required, electric motor, what type of required, what type of drive. Similarly, if the motor has to be, what type of enclosure, what type of IP rating. So all these factor has to be mentioned for a pump selection. We only mention here the pump properties. We did not mention the drive properties here. The second one on the middle one is the centrifugal pump, which is a horizontal type selection. The other factors are all remaining same, but only difference is we went for a stainless steel casing, impeller, and shaft, which we selected for more corrosion fluid. Even for seawater, we can go for stainless steel application, depending on the lifetime requirement, depending on the application, and depending on the client specification. Some clients require stainless steel pump. Similarly, for a gear pump, we can see that the flow rate is lower, 50 meter cube per hour, compared to a centrifugal pump. And here it is mentioning a pressure value like 3000 psi, or we can mention 165 bar, 200 bar, 350 bar, like that. Similarly, cast iron body, material internals, etc. What type of fluid? Hydraulic oil. Assembly to include suction and discharge gauges. Relief valve protection. So this is a requirement for all positive displacement pumps. Require a relief valve because compared to a centrifugal pump, the positive displacement pumps like gear pumps, low pumps, etc. continuously build up pressure in the system. So we need to have a relief valve to protect the system from crossing the design limits of the pressure value. So this is about pumps actually. When we see in the marine oil and gas sector, we see a wide application of centrifugal pumps because it has higher flow rates and it is used for a lower viscous fluids. So wherever water application or lower viscous fluid application comes, we generally prefer centrifugal pumps. And positive displacement pumps like gear pumps, low pumps, etc. are used for piston pumps, etc. are used for higher viscous fluids like oils, hydraulic fluids, or more thicker viscous fluids. Similarly, for food processing industry or pharma industry, etc., we use a low pump. So there is a difference. So now we may have a doubt why centrifugal pumps are used in the cargo system or in the pumping oil system in marine vessels or oil and gas sector, etc. Because of the high flow rate, we use centrifugal pumps. We design the pumps suitable for the high viscosity for such condition. And centrifugal pump is used in cargo systems or oil pumping systems because of the high flow rate. Or in other terms, we can say oil systems, we generally prefer gear pumps, etc. But because of the high flow rate, we use centrifugal pumps in marine vessels and offshore application, oil and gas application, refineries, etc. So that is about pump specification. We almost reached the end of presentation. Now we can go to the Q&A section. So whatever questions and answers we can see. Okay, centrifugal pumps application. Yeah, application of centrifugal pumps is for all kind of application like fire water pumping. Any kind of water well pumping, we can use centrifugal pumps where suction Npsh requirement is met. Okay, video has no sound. Actually, sound was there with the video, but I think it's not transmitted with in the webinar. Okay, in the video, we will be sharing the video recording. The sound for videos we can see in the recording. Life factor in years indicated. Yeah, life factor in years actually, it is just for a comparison to see the material which has a more life factor. It is not directly compared to selecting of this material will yield 8 years, selecting of this material will yield 4 years. It is not like that. It is a life factor comparison values just to give a understanding of which type of materials has more life factor. It is not directly related to the years of operation. So please don't misunderstand that. This is just a comparison to see which material to be selected for more life period. So there is just a comparison. Okay, there is another question. How flow rate normally calculated? Normally flow rate like meter cube per hour. Like what is the volume of fluid pumped for time based on time, like meter cube per second. meter cube per minute. Meter cube is like we are giving a meter cube is like 1000 liters. So we can also give liter per minute, liter per second. So that is something which is calculated by the flow rate. What is the volume of fluid pumped based on time? Okay, maybe a vast topic, but you summarized it well. Okay, thank you. Which standards specify for Npsh and Npshr margin, and how much minimum margin to be specified? It is a wide application to keep 0.5 meter difference between Npsh available and Npsh required, or 10% of the value, whichever is higher. We have to go for the higher value. But on a safe side, keep more than 0.5 if available, if possible, but keep at least 0.5 meter difference to avoid cavitation. So there is no standard which specify. It is a widely used industrial practice, which is based on the reference which we received, which was received in the industry. Okay, so that is the margin to be specified. Please share e-certificate of this webinar. Okay, let me check. Let me see that. If possible, I will share it. Let me check. Okay, we have been ordering pumps as the tech team tells us, not knowing what is NBS, etc. Now we know. Well, thank you. So NPSH is a factor which is very important for a centrifugal pump selection. So when we get a pump data sheet, we can see NPSH required for a pump, which is specified by manufacturer. So we can ask if you are in the project side, or if you are in the implementation or supervisor side, you can ask the engineering team or the concerned technical person to calculate the system NPSH available. When we select a pump before ordering, you can ask him to calculate the NPSH available and compare the values with the NPSH required, which is specified in the pump data sheet. We may get 5 or 6 offers generally through procurement department. So this offers we compare with the NPSH available, which helps us to select a pump which meets the requirement of the margin. So which pump can be used for water fluid 90 degree pH 8 at 7 to 15 meter? Okay, we can use centrifugal pumps, but if it is a 90 degree Celsius pump, we cannot install the pump in the same level of the tank. The pump has to go much lower, like boiler feed pumps. For boiler feed pumps, we use centrifugal pumps, but to avoid cavitation, because boiler feed pumps has higher temperature, like 60 to 75 degrees Celsius, the temperature rises. So in that case, what we do is we bring the pump to a lower level. Like if you see a marine ship, or if you see a plant where the boiler is placed, the feed pumps which handle this higher temperature fluid will be located much in a lower level to attain the cavitation, to prevent the cavitation. So pH 8, okay, at 7 to 15, yeah, we can use centrifugal pumps, but only this factor has to be considered. To prevent cavitation, we have to locate the pump on a lower level compared to the fluid level. Some pumps we can see more than one impeller. What is the use of the pump and advantages? Okay, more than one impeller is actually for multi-stage pumps. So with one impeller, we have a limitation for the pressure achievement. But if we need high pressure applications, for example, the deep well pumps or raw water pumps used in the offshore oil rigs, it is a multi-stage pump. So because it needs to pump at a higher heights or higher head, so at each stage the pressure adds up. So if we have two impeller, it actually the pressure is adding up. Similarly, we have 3, 4, 5 multi-stage impellers. So multi-stage impellers are provided to get more higher head requirement or head application. So the use of pump we described for higher head. Advantages, we get more head on the and it is compact compared to adding multiple pumps in the system. We can add more impellers which can create multi-stage application. What kind of fluids are Npsh value important? Generally, centrifugal pumps have the Npsh requirement. Centrifugal pumps are used for low viscosity fluids. So any low viscosity fluid like water or another kind of low viscosity fluid, it can be another kind of fluid. It can be some not oils, it can be other type of fluids, or it can be even oils. So these fluids, these low viscosity fluids have Npsh value is important. How the specific gravity related to the capacity of the pump? How can determine the pump capacity for different type of fluid? Okay, specific gravity is actually related to like the atmospheric pressure which is acting. The specific gravity of the just a minute. How the specific gravity related to the capacity of the pump? How we can determine the pump capacity for different type of fluid? Pump capacity. No, normally pump capacity we are not determining like by fluid type. Pump capacity is determined by the system requirement. Like what is equipment requirement, or what is your filling time requirement for a tank, or what the equipment needs the flow rate of a certain fluid, maybe fresh water or feed water, whatever. So the equipment provides the flow rate requirement, which we go for the we go for a higher capacity pump. Like if the equipment needs 100 meter cube per hour, or if we are selecting a fire pump which needs 700 meter cube per hour, so we go for a pump which is above that value. That is how we select a pump. So specific gravity of a fluid affects the pump property, because specific gravity requirement is mentioned by pump manufacturer in the pump datasheet. So see whether the fluid specific gravity matches with the pump manufacturer datasheet specific gravity, and this has to be considered for pump selection. Okay, certain project Npsh available is very low and margin is also very less, 0.1 or 0.3. Is it okay to specify 0.3 meter? It is okay. We have to in some cases we go for a tighter margin, but it is advised to keep at least 0.5 meter margin. 0.3 is acceptable. Theoretically, it is acceptable. Even practically, it will work fine. Only thing, 0.5 margin is given to prevent a situation where the suction lift was lower compared to the design criteria or something like that arise. Even then, the pump should not breach the barrier of calculation. So that is why we keep a safe margin of 0.5 meter. Even 0.3 meter is acceptable. Next question, what is a critical point where we select centrifuge or positive? The critical point is like what is the flow rate requirement, what is the viscosity of fluid. So that is based on the that is the most important point. Like if you need a high flow rate, we have to go for just a minute. Yeah, we have to go for a centrifugal pump or a dynamic pump, which is a centrifugal pump. And for positive displacement pump, where we need higher pressures and the viscosity of fluid is higher, like thicker fluids, but we can compromise flow rate, where the system is willing to compromise flow rate, like only low flow rate requirement is required. We can go for a positive displacement pump. Okay, we will go for next question. Can I know the maximum flow rate variation percentage from its duty point during operation in case of centrifugal pumps? Will there be any vibration of other issues due to the flow throttling? Yeah, flow throttling for centrifugal pumps, to prevent vibration or other issues, we have to throttle on the discharge side. Don't go for a throttle on the suction side. Even if there is a suction isolation valve, don't throttle the valve of centrifugal pump on the suction side. Throttling has to be done on the discharge side. It is a compulsory and strict requirement. It is specified in the engineering standards of various organizations or operation standards of the like oil and gas sector, offshore rigs, marine vessels, etc. Operator side, it is clearly mentioned. Throttle the valve for a centrifugal pump on the discharge side only. to prevent any type of cavitation issue or pressure variation issue. Also, what is the maximum flow rate variation from the duty point? Okay, for centrifugal pumps, like it should not be run less than 50% capacity. So that is a general requirement. Like if the pump has 100% capacity, and it should not be reduced to a duty point less than 50%. 50 to 100 in between, we can select any point. 65 to 70 or 75% is fine. We can go to the next question. Can you please explain a little bit about portable pump? Is it centrifugal or application of portable pumps, especially in marine industries? In the marine sector, generally portable pump, we use this diaphragm type pumps. We don't carry a centrifugal pump, which needs a lot of requirements, like we have to see the Npsh, suction lift, etc. But for a diaphragm pump, these factors does not affect. We can operate a diaphragm pump in airy areas. It's very light. Even with aluminum body construction, it's very light. So we can see these pumps very widely in the marine industry, marine vessels, offshore, oil rigs, land rigs, etc. All these applications, we see portable pumps as the diaphragm pumps. Also, the driving fluid, we can give air for diaphragm pumps. So air is widely available in all the areas of the vessel or rig, etc. So diaphragm pumps are widely used. So we'll go to the next question. What are the details of purpose of a lift pump and booster pump in marine piping? Okay, lift pump is actually the suction, like if you use a centrifugal pump for lifting application, it will be installed for lifting the water and pumping up to certain height. But booster pump is used where we need more flow rates and higher pressure. Like if we need to take the water from a certain height to more higher height, we use a booster pump. For example, if we compare an offshore oil rig, or if we compare a marine ship or marine vessel, if the fire pumps are running, if the fire pumps will supply water to the entire fire system line in the ship. But on the heli deck, which is mostly on the upper part of the vessel or offshore oil rig, it is at a height certainly. So at this area, the heli deck will have a certain flow rate and certain pressure requirement. To achieve that, we do not upgrade the entire fire pump to that. We generally, on an existing vessel, if you are adding a heli deck, we add a booster pump to provide certain requirements to specific areas. Like heli deck, if it is specified, we need 7 bar or 600 gallons per minute at 7 bar pressure. So in that case, we provide a booster pump to meet that criteria. Okay, next question. We'll see much informative and useful presentation. Please share this presentation slides and video. Yes, of course, we will be sharing the video. Also, next question, salvage pump is a submersible type. Yes, salvage pump is generally submersible type. Even the defense ships which have salvage pumps in every compartment or compartment-wise, whichever applications we use a salvage pump, it is generally submersible type. It is usually a pit is made to keep the pump, to keep it dipped on the fluid. And in case of a flooding in the compartment, the salvage pumps work much efficiently. So it is a submersible type generally. We can use other types also, but generally it is submersible type. So I think we answered most of the questions. There I saw a few comments. Video is without audio. Actually, audio is there, but please see the recording of the video. It has audio, which is played along with the video. Okay, so if there is more questions, we can address it, or else we will wind up the session. Okay, there is one more question. Pump with NAB material are costly. Yes, pump with nickel, aluminum, bronze is costlier than cast iron or normal bronze. But the nickel, aluminum, bronze is widely preferred. For example, when we select a fire pump for offshore application, we generally prefer if the if the client is not willing for spending much costly option, we go for a bronze body or bronze impeller. But if the cost is not of a much factor, we go for a nickel aluminum bronze body, like stainless steel impellers and stainless steel shaft, or bronze impeller with stainless steel shaft. So this is the combination we generally select. Nickel aluminum bronze is comparatively costly compared to bronze or cast iron. Okay, so sorry. Okay, so that is about all the questions I answered. If any more questions, please you can put in the Q&A section, or else we will. Yeah, I'll wait for one or two questions. Okay, there is no more questions coming up. Most of the questions are answered, so that is fine. Okay, thank you for attending the webinar. We will be announcing the next topic. All the attendees will receive email. All the attendees will receive a separate email invitation for the next webinar, and it will be widely circulated in the LinkedIn and Facebook pages of Canotech. So that's it. Okay, so thank you. I hope all the doubts are clear. If any more doubts, which are okay, yeah, one more question. E-certificate, please. Sure. Okay, I'll arrange it. Yeah, usually we don't provide e-certificate, but I'll arrange it. No issue. Okay, thank you for the presentation. Highly informative. Okay, very well. Thank you. So, if any more doubts in the which you get it next, we will please send it as email, or you can post a query in our website. There is a part for posting comments on the website. You can post it there, or you can directly contact me. There is a phone number given in the website. You can put the queries through WhatsApp or email. That's fine. Okay, so we will address all the queries. If anything, any questions which was raised here today is still not clarified well, please raise it through email or WhatsApp. We will clear it. Okay, so thank you for attending. Okay, bye. Yeah.